So how do we calculate these on a calculator, just of interest? 27 to the power of 2 over 3, we type in 27, hit the x to the power value, and then open brackets 2 divided by 3, close brackets, equals, and you should get 9. So some further examples here. Express as a rational number 216 to the power of 3. Well, that's the nth root of 216. Third root 216 is 3. That's invoking this rule here. And we'll work again with it here, where we've 8 over 27 all to the power of a third. Now we mentioned this earlier, so we'll rewrite it like this, and then we can invoke this rule again, so that 8 to the power of a third is the same as the cube root of 8, and 27 to the power of a third is cube root of 27. It's 2 over 3. So what about these ones? Right, without using the square root sign. Square root of x is x to a half, okay, because that's the nth root of a is a to the 1 over n. So we're assuming that there's a 2 there, so that's a to the half. This is the n, 1 over n, okay. The fourth root of a cubed is the same as a to the power of 3 over 4. That's one of those a to the m over n equals the nth root of a to the power of n, a fractional indices example. And find the value of 16 to minus a half. Well, get rid of the minus sign by invoking the rule that puts the a to the minus n is 1 over a to the plus n. That's here. And that's the same as the nth root of a, which is the square root of 16, is equal to 1 over 4. What about 1/9 divided by a half? Let's get rid of the negative sign here. That's the same as 1 over 1/9 to a half. That's the same as 1 over 1 to a half and 9 to a half. And that's the square root of 1. That's the square root of 9. So it's 1 over 1 over 3. That's the same as 1 over 1 times, invert this because you're multiplying now, not dividing. 3 over 1 gives you 3. 64 to the power of 2/3 is basically the nth root of 64, which is our a, all squared is 4 squared is 16. What about this? Rewrite using the square root sign. So a to the half is the same as the square root of a. A to the power of 1 over n is equal to the nth root of a. A to the 2/3 is the same as the cubed root of a, all squared. A over x to the half is the same as a to a half, divided by x to a half, which is the square root of a by the square root of x, or you can say the square root of a over x. Okay. Okay. This example, question 11, page 292. If a is 64 and 2/3 and b equals 3 to the minus 2, write a and b as rational numbers. So 64 and 2/3 is the cubed root of 64, all squared. Okay, that's 16. 3 to the minus 2, get rid of the minus, the same as 1 over 3 to the power of 2 is 1 over 9. Hence find the square root of a over b. Well, that's the square root of 16 over 1/9. Square root of 16 is 4. Square root of this is 1 over 3. So now we 4 divided by 1 over 3 is the same as 4 times 3 over 1 is equal to 12. Question 16. Express 81.5 times 9 minus 1 divided by 27 to the power of 2 over 3, all in the form 3 to the power of x. So we have to somehow whittle it down to 3 to the something. So 81 to the half is the same as the square root of 81, and 9 to the minus 1 is the same as 1 over 9. So we're working towards making them all work into 3's. And 27 to the power of 2/3 is the cube root of 27 squared. So we've 81, square root of 81 is 91, and we'll write over 1 for balance, times 1 over 3 squared, which is our 1/9, all over 3 squared, which results from here. So that's 3 squared times 1 over 3 squared divided by 3 squared. So these two will cancel, and we're left with 1 over 3 squared, which is the same as 3 to the minus 2. That's written in 3 to the x form. Let's look at some problems which associate themselves with equations involving indices. So if we have an equation like 5 to the power of x equals 5 to the power of 2, then x must be equal to 2. Okay? Because basically, if we have a base value to the power of x equal to the same base value to the power of y, x must be equal to y. Okay? So it has to be the same letter or number here. So let's try 25 to the x equals 125. Let's solve for x. So what we need to do is we need to write both sides to have the same base number, and in this case it would be in terms of 5. Okay? So 25 to the x equals 125. So 25 in terms of 5 is 5 squared, all to the x, so to keep the x there, and 125 in terms of 5 is 5 cubed. So now we've 5 to the power of 2x, because the power to a power we multiply them, is equal to 5 cubed. Once we have this set up where we have the two bases the same, we can just pull down the indices and equate them to each other from this rule here. So 2x equals 3, x equals 3 over 2. Okay, now the book says write each of these as whole numbers or fractions, when really it could or should say solve for x. So 4 to the x equals 16. I need to rewrite this in terms of a base 4. So I have 4 to the x equals 4 squared. Now I have the two bases the same. I pull down my x and my 2. X is equal to 2. 16 to the x equals 64. So I'll go and try and reduce both sides to the simplest form, base number 4. Well, not simplest form, but in terms of 4. So 16 is 4 squared, all by x, and 64 in terms of 4 is 4 to the power of 3. So 4 to the 2x is equal to 4 to the 3, so they're the same. So now I say 2x is equal to 3, x is equal to 3 over 2. 3 to the x equals 1 over 27. Well, 3 to the x is the same as 1 over 3 to the power of 3. So 3 to the x is the same as 1 over 3 to the power of 3 is 3 to the minus 3. So we can, these are the same base now, 3 and 3, so we can say x is equal to minus 3. 25 to the x equals 1 over 25. That's the same as 5 squared. I'm going with 5's here now on both sides. 5 squared all by x is the same as 1 over 5 cubed. It's another way of writing 125. 1 over 5 cubed, another way of writing that is 5 to the minus 3. This is 5 to the 2x, so 2x is equal to minus 3, because my base numbers are the same now. X is equal to minus 3 over 2. Now, what about this one? Express as powers of 3, 9 to the power of 2x minus 3. Okay, let's do that. So that's the same as 3 squared, 3 to the power of 2 times 2x minus 3, which is the same as 3 to the power of 2 by 2x is 4x, and 2 by minus 3 is minus 6. Okay? Now, express 1 over 27 in terms of powers of 3. That's the same as 1 over 3 cubed is 3 to the minus 3. Hence, solve this. So, we know that this is equal to 3 to the power of 4x minus 6. This is equal to 3 to the power minus 3. The bases are the same. That's why they asked us to do that. So we can bring down our powers and say 4x minus 6 equals minus 3. 4x equals minus 3 plus 6, bring it over the bridge. 4x is equal to 3, x is equal to 3 over 4. Okay, another example here. 3 to the power of x minus 2 is equal to 81. So let's rewrite this in terms of 3. That's 3 to the power of 4. So 3 to the x minus 2 equals 3 to the power of 4. They're the same, those bases. So we can just pull down x minus 2 is equal to 4, x equal to 6. 5 to the power of x equals 125 over root 5. So that's the same as 5 cubed over 5 to a half, which is the same as 5 to the power of 3 minus a half. So 5 to the x is equal to 5 to the 2 and a half, which is equal to 5 to the 5 over 2. So 5 to the x is equal to 5 to the 5 over 2. So they're the same. I can pull down my x is equal to 5 over 2.